Good morning everyone and welcome to 2024's Reefs Go live. We're coming to you live from a dive site called Jackson's Reef here in Little Cayman. My name is Abby and I'm the Head of Fundraising and Engagement here at CCMI, and I will be your topside host today, alongside Ryan, our Education Assistant, who will be your underwater host. So Ryan is wearing specialised scuba gear which allows him to hear me and speak to all of you. Let's take a minute and say hi to him now.
Hello everyone from all around the world. We're so excited to have you with us here on the Reefs of Little Cayman. If you have any questions or comments, please put it in the chat and we'll reply to as many as we can. To get things started, send us a message telling us where you're from.
Yes, so throughout today's broadcasts on our physical ocean, we really want to hear from you all, so make sure to send your questions and comments through in the chat. So bringing you the show, Ryan and I have an amazing team from CCMI with us, both on the boat and in the water. So let's say hi to them too.
Hi.
Thanks guys, and I can see that we're already getting some messages through, so let's have a look where you're all joining from. So we have Bill from Oregon, Alison and Kimberly are joining from Shelby Township in Michigan. We have Sue joining from Birmingham in the UK, Rachel from Lichfield in the UK, and Miss Amanda's grade 2 class at CIS in Grand Cayman. Oh, and Beacon Trees Elementary 6th grade, and Melissa from Blossom Village. So thank you all so much for joining us today. So let's get started, but please make sure to keep sending messages in the chat throughout. So if we start with the basics of why it's important to know about the physical properties of the ocean. Well, understanding things such as the ocean's density and temperature, as well as how light and sound change underwater, is important because it helps us to understand how these properties shape life under the waves. These properties also impact our global climate, which affects our entire planet. So essentially, understanding these properties helps us to make smart decisions about protecting marine resources and using them sustainably for the future. Understanding the ocean's features helps us to preserve the world's health and balance. So, to begin with, Ryan, could you tell us a bit about how the physical properties of the ocean differ from those on land?
Great question. But before we begin, remember, if you do have any questions, please ask us and we'll get back to you. Remember that no question is a silly question. So it all comes down to the water molecules themselves. Gravity is like a giant magnet pulling everything down towards the Earth. So you can think of air molecules as bouncy, floaty balloons that are less tightly packed together. This means that gravity has a weaker pull on them. Whereas water molecules are very tightly packed like jelly beans, meaning that gravity has a stronger effect, making things feel more heavy or dense, which is why it feels like you're swimming through a pool of like sticky, squishy jelly. So it is these differences in the air and water molecules that affect how light, sound, and color travel through the water. This helps to shape the unique underwater environment that we have and many of the animals that we have on the reef. Abby, could you explain a little bit more about this?
For sure. So, if you look behind me or you look out at the ocean, have you ever wondered why it's so blue? Well, this is because sunlight has many different colours within it, and those colours actually filter out at different depths in the ocean. So reds and yellows filter out first, whereas blues and greens can travel deeper into the water. So this is why the ocean is so blue. It's kind of like a huge natural colour filter. So as we go deeper into the ocean, there is less light and we're left with darker and cooler conditions and only blues and greens. But sound, on the other hand, travels much faster in water than it does in air. This is because of how tightly packed the molecules are in water, which allows for easier transmission of sound from one molecule to the next. As we go deeper into the ocean, transmission of sound is even faster because the water molecules are even more tightly packed because of the pressure. So I'm going to pause now and have a look if we have any questions around sound or light and how that changes underwater. our first question is around where in the ocean that the light actually filters down to. So there is a zone in the ocean called the twilight zone, which starts at around about 200 meters deep and goes to about 1,000 meters deep. And there's very, very little light at this point in time. So this is essentially where it's almost pitch black and it's very cold as well. But interestingly, even though it's dark and cold, scientists have recently found that there is around 10 times more biomass in this area of the ocean than they originally thought. So even though it looks like there might not be as much there, it is much more biodiverse than we initially realised. Let's see if we have any others. So we also have some questions around coral bleaching. So Ryan is going to touch around on the basics of coral bleaching, why it happens and what that actually means for our reefs in a while. Obviously with last year's really warm water event, there was a lot of bleaching, so I imagine that is hot on everybody's mind. Bleaching is horrible to see, and it's not always a good sign, but it's also not the end of the world. It doesn't mean that the corals are dead. As long as we protect them and we could remove other pressures, they may well recover. But we will talk about bleaching a lot more today and pretty much throughout the entire series, so don't worry, we will come back to that. Okay, so now let's move on to how the changes in physical properties in the ocean actually influence life underwater. Ryan, can you tell us some more about this?
I would love to. So, if we look around on the reef, a lot of the animals have become very well adapted to life in the water. A lot of the fish have a streamlined or slender body to help them move through the sticky jelly soup that is the ocean. The fish are also able to breathe underwater due to their gills. So they bring in water through their mouth, and when they pump it out over their gills, they're able to extract oxygen. Some of the fish even have a special organ inside of their body called a swim bladder. Now this is an air-filled sac, which allows them to maintain their buoyancy or balance in the water column. Kind of what like scuba divers where when we go diving. So we're able to dump some air out and add some air in to help us stay balanced in the water. Now, I have an interesting question for our students. Do you think that fish and other marine creatures have ears?
That is an interesting question, Ryan. So what do you think? Has anyone ever seen ears on fish, and how do you think they hear underwater if they don't have ears? If you put your answers in the chat, and we'll come back to that shortly. In the meantime, let's review what we've learned so far. So, we know that molecules are much more tightly packed in the water than they are in air, and that allows for faster transmission of sound, and that light and colour are lost as we go deeper into the ocean. We also know that marine animals cope with the density of water in many different ways, from their unique body shapes to their breathing techniques. So now let's move on to how different animals are adapted to light and colour changes underwater. Ryan, can you give us some examples of this?
Yeah, Abby, there are numerous examples down here. So the corals that you see around me on the reef are very well adapted. They have a photosynthetic, symbiotic algae inside of them. This means that they have thousands of tiny little plants that are able to convert sunlight energy into food through a process known as photosynthesis. A lot of them come in different shades such as purple or orange, and this helps them to attract the right kind of light to be able to grow and make food. Some of them even have special pigments inside that help to protect them from the harmful UV rays of the sun. Kind of like when we wear sunscreen at the beach. A lot of the reef fish as well are going to be very brightly colored in these shallow waters. This helps them to blend in or camouflage on the reefs to kind of hide away from predators. Sometimes they use those colors to help attract mates, or they can even use them to confuse or scare off potential predators as well. In the shallow waters, the fish also tend to have smaller eyes due to the abundant light that we have here. So, going back, let's find out what our student said about ears on fish.
Thanks, Ryan. So those were some really interesting examples of how the physical properties of the ocean influence life underwater, especially life on the beautiful shallow reefs here in Little Cayman. So let's go back to fish ears and see what you students had to say. Okay, so we have CIS grade 2, don't think fish have ears, but they hear through movements and vibrations. And Kobe from CIS thinks that fish have ears, but you can't see them. And Beacon Tree, Miss Galbraith's class, say that they don't think fish have ears. Okay, so most of you are essentially really right. So fish definitely don't have ears in the way that we know ears. But they do have internal ears. So sound is really important for fish because it helps them to find food, to navigate, and to communicate. So there are two different systems that fish use to hear. So the first is their inner ears, or otoliths, which they're called, which helps them to detect vibrations and understand them in the water. And the second system is their lateral line. So this is a horizontal line that runs down the length of their body, and this helps them to detect pressure changes in the water as well. Great question, everybody. Thank you. Let's have a look and see what others we have. So this is interesting. So Katie from South Africa says that she has seen ears on seals in Cape Town. It's a great observation, Katie. So yes, so seals are mammals like us, and they breathe air, and they split their time between in the ocean and on land. So the ear flaps that you see on seals, probably more similar to our ears, help them to hear much better when they're on land. So some marine creatures have ears more similar to ours, whereas some, like dolphins for example, have ear holes in the sides of their heads, but they actually use their lower jaw bones to hear. Okay, so let's go and check on Ryan and the team now. How are you guys doing down there?
We're doing great. Thanks, Abby. It's a beautiful day on the reef.
Great, okay, glad you're doing okay down there, Ryan. So, moving on now, would you be able to tell us a bit more about how different marine creatures have adapted to different ocean habitats, and maybe a bit on how things change with depth?
Increases with depth. So a lot of these animals in the deeper environment have become very well adapted or very well suited to be able to live there. Find them in shades of black, red, or even see-through to help them hide away from potential predators. Some of them will even bioluminesce in this deep water to communicate. A lot of the corals that live in these deeper waters are on mesophotic reefs. So coral reefs that are about 30 meters down to about 200 meters have become very well adapted. So they have larger cells that have a pigment inside called chlorophyll. Now this is able to convert sunlight energy into food, which is usually seen in plants. Some of them are even able to just feed upon the tiny passing animals in the currents. They're also very well adapted to the low temperatures due to the low amount of sunlight that reaches that depth.
Thank you, Ryan. Those are some really interesting adaptations, and I actually have some cool new research to share with you all too. So, scientists have found that some corals are actually able to switch their feeding habits if they don't have enough light reaching them, or if they don't have enough algae within them, like Ryan mentioned, to be able to photosynthesize for food. So, instead of mostly relying on sunlight for survival, some corals that don't get enough light, like deep water corals for example, they can switch their main feeding habit and rely mostly on catching tiny little animals that float around in the water column instead for survival. This is really good news because it could mean that corals are stronger than we think for dealing with warming waters and climate change in the future. So, speaking of climate change, Ryan, could you tell us a bit more about what this is and how understanding the physical properties of the ocean can help us with this issue?
Great idea, but before we continue, let's see if our students have any questions for us.
Great, thanks Ryan. We actually have a lot of questions coming in, so let me have a look. So we have one which is, let me just find it, bear with me. So Miss Amanda's grade 2 class have asked if light travels faster in water than air. So the speed of light wouldn't change in the water, but it can sometimes change angle, which is quite interesting. So sometimes when it hits the surface of the water, as light travels in straight lines, instead of carrying on in the exact same straight line, it almost shifts a little bit, and it can kind of fragment and break up as well into the different colours that we were talking about. And we also have another one that asks, so Jason asked, how do fish sleep? So a lot of fish don't actually sleep the way we sleep. They rest. Some of them wedge themselves into corals, and they're more kind of catnapping or snoozing than they are actually sleeping. And some fish, such as sharks, for example, particularly nurse sharks, they have specific organs within them that continually pump water around their body, because one of the main things with gills is that they need moving water across the gills to be able to breathe properly. So that allows them to be still. And that's often why you'll see nurse sharks on the bottom of the ocean, and they definitely look like they're sleeping most of the time. So Ryan, another question, if you could take this one. So what fish can you see down there, Ryan? That's from Nixon.
What was the question again?
What fish can you see down there? And Nixon's also asked, so what types of fish can you see on the reef today?
So if I look around, I would say the most common fish I can see on the reef right now is probably called a Creole wrasse. So it is a bright blue, small fish that tends to swim about the reef and can sometimes school together.
Great, thank you, Ryan. So also, Landon wants to know, what is the closest you've been to a fish while swimming, and how deep have you gone to see the fish?
Out here, I would say the fish that I've gotten the closest to is probably a Nassau grouper. So if you're going nice and slow and just kind of enjoying your dive, they can sometimes get right up next to you, and I've had one be like inches away from my face.
Thanks, Ryan. That's all of the questions at the moment from us.
Great. So if we want to get back to what climate change is about, understanding this issue is really important for us to be able to help our oceans. So with climate change, a lot of the time we see warmer seawaters. This warmer seawater really affects our coral reefs and can lead to something called bleaching. So bleaching is when the corals lose that symbiotic algae inside of them and end up turning white. Now, a bleached coral isn't dead yet, but they are more prone to potential disease and death. Scientists are studying deeper water corals to see how they can help us understand coral adaptation and how they can fight disease or fight for having better tolerance towards the warming seawaters that we see with climate change. Now, it is very hard to study these corals that are in deep waters or in very remote areas. Abby, would you be able to talk a little bit more about the research that we're doing?
For sure. So CCMI is actually leading ocean exploration with our Darwin Plus Seamounts project that we have underway at the moment. So in this project, our researchers are exploring uncharted waters to document marine life on seamounts up to 50 meters deep. So far they have been to 12 Mile Bank, which is off the coast of Grand Cayman, and they plan to visit Pickle Bank, which is off the coast of Little Cayman, this summer. So this project is happening because these habitats may be home to really rich biodiversity with fewer impacts from human activities because of how far away but also how deep they are in the ocean. So this could potentially offer hope for the future of Cayman's coral reefs and act as a refuge for corals from a warming ocean and climate change. So, speaking of human impacts, Ryan, could you tell our dive buddies a little bit more about the other recent research that's happened at CCMI?
Yeah, so CCMI has done some amazing research. We had the opportunity during the COVID lockdown in the Cayman Islands to study quiet oceans and how that affects reef populations of fish. So, what we found was that when things are quieter in the ocean, so there's less shipping, water sports, and pollution, we see a lot more fish on the reef, especially plant-eating fish. Now, this is really important for reef health. We also found that the fish health, or what we call fitness, was a lot higher as well. So the fish that we saw on the reef were feeding, socializing, and reproducing better than before. I think we would all be able to relax a little bit more if we were less stressed from noise and pollution.
Yes, I agree, Ryan. Wow, so we've already covered some really important research today and learnt about the fundamental principles of the ocean as well. So we're starting to near the end of our broadcast. So Ryan, to summarise, could you tell us all a bit more about why we do what we do and why this knowledge is so valuable?
Our ocean ecosystems, especially our coral reefs, are very vital to the world. So, by understanding how our impacts affect our oceans, we are able to better protect them through proper planning and management. Whether you live by the coast or you live inland, we rely upon healthy coral reefs. So oceans can really help us to reduce the impacts of climate change. Most of the heat that reaches the Earth is soaked up by the ocean. And what does go back into the atmosphere helps to drive our water cycle. So this means we get our rain, which then fills our dams and waters our food. So we are very reliant upon our oceans to be very healthy.
You're so right, Ryan. We need a healthy ocean to survive, which is why understanding it and learning more about it through research is so important. So we are nearly out of time, but I can see that we've got loads of questions coming in, which is great. So I'm going to take a minute and answer some more of those while we're here. So Marcel has asked what percentage of corals around the world have been bleached. So I'm afraid I cannot give you a number off the top of my head. However, this is increasing year on year. Previously, bleaching was much more rare and it was more localized into smaller areas. Last summer we saw bleaching across the entire Caribbean during the summer, and then we saw it in different parts of the ocean and different parts of the world in the southern hemisphere in a different part of the year. So these warming waters are becoming increasingly common, and the predictions are that this will keep happening. So the percentage of corals that are bleached is increasing. So our last episode in Reefs Go Live this season, which is on the 7th of June, will actually talk about the coral bleaching that happened here in the Cayman Islands and coral bleaching more in general. So we will be able to give you some information about how many of the corals bleached here in Little Cayman, because CCMI have been monitoring this since last summer, and a bit more about what that could mean for the future, and how we can go about protecting our corals when they are struggling with warming waters as well. Thank you for that question. Let's see what else we have. So, Alison has asked, how did Pickle Bank get its name? Which is also something I don't know the answer to, but I'm really, really interested. So if anybody does, please put this in the chat. It would be really good to know the answer to that. So Hugo has asked, how do corals grow with no seeds? So corals spawn. Similar to some fish and some plants on land, they also spawn. And these are tiny little eggs and sperm that potentially, hopefully, will meet in the water. They then fertilise and settle and recruit on rock, which would then grow into a coral. But again, we're going to cover this in so much more detail on the 8th of May. So that is our reproduction on the reef episode, and we'll talk about that version of coral spawning and how corals can grow, and also another way that corals can grow, which is called asexual reproduction, where parts of corals break off and then they essentially land somewhere and start to attach themselves to that piece of rock, and then that little broken piece of coral is essentially a new coral. So it's quite a complicated answer, which is why we've done a whole episode on that on the 8th. So please join in for that one. Okay, so Ryan, would you take this one? Are you ever scared to swim in the dark and in the deep? And that's from Dahlia and Emily.
I would say, for me, I'm not really. So, the unique thing for me is most of my dive training has been from Northern California. So, this is very, very different from what I'm used to. For me, I'm used to cold water and very low visibility. So, being able to see potentially less than 10 feet while I'm doing my entire dive. Being out here is very, very different from what I'm used to, but it is always a good idea that when you're in the water, just kind of keep your head on a swivel to see what's swimming around you.
Thanks, Ryan. So we are pretty much out of time now. So we have discussed a couple of our other episodes, but our next episode will be on the 12th of April. And in this episode, we're going to talk about research on the reef and why investigation is so important. We'll also touch upon some of CCMI's research that's going on at the moment, and talk about our really exciting sea cucumber project and some other really cool things. So that's the 12th of April at the exact same time. And we'd also really love your feedback from today. So there is a link to a survey in the chat. So if you could all take a few minutes to fill that out for us, that would be great. And we'll incorporate any comments and feedback into the next episode as well. So before we finish, Ryan, any last words from you?
Yes, I would like to say a big thank you to all of our dive buddies for joining our live lesson today. I'm hoping that you're leaving this feeling very curious and wanting to learn more about the ocean. Thank you again, and we will see you guys